Welcome to this video on factoring quadratic trinomials. By the end of this video, you should be able to rewrite quadratic trinomials in factored form. Alright, so let's take a look at our review. I'm giving you a pair of binomials, and I want you to multiply them together. Okay, so x times x gives you x squared. X times 4 gives you 4x. So we've distributed this x to both things in the other parenthesis. We've got to come back and get the 3. So we get 3 times x, which is 3x, and then 3 times 4 gives us 12. Before we can say we're finished, we have to combine our like terms. So we have x squared plus 7x plus 12. So when we multiply them to get these two binomials together, where did the x squared come from? The x squared came from multiplying x times x. Okay. Where did the 3x and the 4x came from? Well, the 3x came when we multiplied 3 times x. And the 4x came when we did x times 4. Right? Where did this 12 come from? The 12 came when we did 3 times 4. Okay. And then where did this 7x come from? That came from combining like terms. So what we're going to do today is, before I've given you the two binomials and asked you to multiply them together, today I'm going to give you this trinomial and ask you to write it in the factored form of these two binomials. To do this, you need to look for some factors of these n numbers. 3 times 4, they multiplied to 12, but they added to 7. So that's a big part of what we're looking for. So what multiplies to the end, but adds to the middle. So we had, this was 3 times 4, and this was 3x plus 4x from here. Okay? So we're going to use that, and we're going to do some grouping like we've done previously. So a quadratic polynomial. Quadratic has the highest degree, or the highest exponent, of x squared. This is the form that we're going to be looking at. ax squared plus bx plus c. A is always next to the x squared term. So if I refer to what is your a term, I'm always referring to the coefficient next to x squared. B is always the coefficient next to the single x. And c is always the constant. So we're going to be looking for two factors that multiply to a times c. So we're going to multiply a times c, but that they add to whatever b is. So a times c, and this will be, you're going to add to get to b. All right, so let's give this a try. If I multiply a times c, that's 3 times 10, I get 30. And this is a positive 30. Whenever you have a positive number, the only way to get a positive number through multiplication is adding two positive numbers, multiplying two positive numbers, or multiplying two negative numbers. So we're going to look through this and decide which these have to be. So we're going to make a list of all the factors of 30 and see if we can come up with two that add together to give us 11. So I always go in order: 1 and 30, 2 and 15, 3 and 10. There's 4 does not go in, but 5 and 6 do go in. So I have to get to a positive 11. That means both of my terms have to be positive numbers. Which of these pairs will add to 11? They multiply to positive 30, but I need them to add to positive 11 in the middle. And that would be 5 and 6. Both of these will be positive. What we're going to do is kind of like what we're up here. We have 11a, just like we had 7x. We're going up here, and we're going to split it into these two. So we have an a variable. So here's what we're going to do. We're going to write 3a squared, but instead of 11a, we're going to say plus 5a plus 6a plus 10. Because 5a plus 6a is 11a. That's what we did here. We were going down this way, but if we go in reverse, you'll see how the 7x was split into the 4x and the 3x. Our next step is to take it back to here. Now, I have 4 terms that's grouping. Anytime you have 4 terms, so I'm going to split right down the middle. And I'm going to work on the left-hand side first. It doesn't really matter which side we do. 3 and 5 have no factors in common, but they do have an A value in common, so I can take out an A. Okay, so I have a GCF of A, and what's left behind is 3A, because one of the A's will cancel, plus 5, because both those A's will cancel. Okay. Now look at the right-hand side. We have a positive value there, so we say plus. What goes into both of those numbers, 6 and 10, is a 2. They have no variable in common, so it's just the 2. And what's left behind, 6 divided by 2 is 3, and the A cannot simplify. And 10 divided by 2 is 5. When I come back and look, I've got 3A plus 5 in both of these places. That's my GCF. And then A plus 2 is what's left over. That goes in the other parenthesis. There are my 2 binomials. If I multiply these back together, I'll end up right back where I started from. Okay, let's try it again with number 2. A, you see how there's not a number there? That's because it's really 1. So we have A times C. So factors of a positive 6, which means we either put positive, positive, or negative, negative. So we have 1 and 3, sorry, 1 and 6, or 2 and 3. Those are our only choices to get to 6. I'm trying to add to a positive 5, so both of these would have to be a positive number. So you have to be real careful with the signs, because 6 minus 1 would give us 5, but I can't have a minus because my signs have to be positive, so I get a positive 6. So positive 2, positive 3, we're going to slide them in there. X squared plus 2x plus 3x plus 6. So I just split apart the 5x into 2x plus 3x. Split them down the middle. On the left-hand side, there's no constant in common, but they do have a variable, just a single x. So they have an x in common, and when I take that out, I'm left with x plus 2. On the right, they have a 3 in common, but they do not have a common variable because there's only one x. So I say plus 3 because it's positive, because the leading coefficient is positive. And when I divide that out, I'll get x plus 2. My GCF is x plus 2. What is left behind is x plus 3. So we're going to skip number 3. We're going to learn out how to do that kind tomorrow. So let's go straight on to number 4. So you're going to take A times C. 8 times 3 is 24. This is a positive number. So I'm either both factors will be positive or both factors will be negative. We'll have to decide what's going on. So we got 1 times 24, 2 times 12, 3 times 8, and 4 times 6. We're done there because the next one will just be 6 times 4 and then 8 times 3. We would just turn these around, and the order doesn't matter here. I'm trying to get them to add to a negative 3. If they both have to be the same sign, the only way they're going to add to a negative is if they're both negative. So I am looking for what 2 numbers could give me negative 10 when I subtract both of them. Okay, that's why it's important. This could become a 10 if they had opposite signs, but they do not have opposite signs. They have to have the same sign. So negative 3 and negative 8 is negative 11. Negative 4 and negative 6 is negative 10. That's the pair I'm going to substitute in. So I'm going to rewrite my first term, 8y squared, and I'm going to substitute these in with a y on them. Negative 4y minus 6y plus 3. Now I've just broken the 10y apart so I can factor by grouping. I'm going to split it in half. On the left, they have a 4 in common, 8 and 4, and they also have a single y in common. So on the left, my GCF is 4y, and when I factor this out, 8 divided by 4 is 2, y squared divided by y is y, and then negative 4y divided by positive 4y gives me negative 1. Over here on my right hand side, pay attention, that's a negative leading coefficient. That means whatever we divide by has to be a negative number. 6 and 3 have a 3 in common, so we're going to divide by negative 3. Negative 6 divided by negative 3 is a positive 2, and the y has nothing to cancel with. and 3 divided by negative 3 is negative 1. When I check, my parentheses match, so my GCF is 2y minus 1. And when I divide those out, I'm left with 4y minus 3 for the other binomial. So let's look at number 5. It offers us a chance to see what happens when you get a negative number. So we get 10 times negative 2 gives me negative 20. The only way to multiply to a negative number is to have a positive number and a negative number. So that means the signs of my factors, one will be positive and one will be negative. So let's find the factors of 20. So we have 1 and 20, 2 and 10, 4 and 5. And then it'd turn around and go 5 and 4. So we're done. That's as far as we need to go. So 1 will be positive and 1 will be negative. I'm trying to get to negative 1. So which of these pairs with different adding and subtracting signs will get me to negative 1? So if I have a positive 4 and a negative 5, positive 4 minus 5 is negative 1. This is the pair that I want to substitute in. So I have 10m squared plus 4m minus 5m minus 2. I'm going to split them right down the center. On the left, 4 does not go into 10 evenly, but they share a factor of 2. M squared and m, so they have a single m in common. So my GCF on the left is 2m. When I divide that, 10 divided by 2 is 5. M squared divided by m is m. 4m divided by 2m leaves me just a positive 2. So when I look at the right-hand side, notice the leading coefficient of the right-hand side is negative. So whatever I divide by has to be a negative number. 5 and 2 do not have a number in common, so it's going to be by a negative 1. M, and there's no m here, so it's just negative 1. And when I divide negative 5m divided by negative 1, I get positive 5m. Negative 2 divided by negative 1 is positive 2. I come back to check. My parentheses match. So that's my GCF, 5m plus 2. They've been divided out. What's left over is 2m minus 1 for the other parenthesis. All right, one last one. This one's a little different because we have an x squared and a y squared. It's okay. But we're going to look for what multiplies to negative 28. That it's negative. That means your signs of your factors have to be opposite from each other. But adds to negative 3. So we have 1 and 28, 2 and 14, 3 doesn't go in, but 4 and 7. Okay, so which of these pairs, when combined together with a one's positive, one's negative, will give me a negative 3? If I use a positive 4 and a negative 7, that will work. Only one pair will ever work. You got to pay attention to the signs. So we're going to substitute them in with an xy on them. So I have 2x squared y squared plus 4xy minus 7xy minus 14. And I'm going to split these right down the middle. So let's just look at this left-hand side. There's a lot going on, so just pay attention. So 2 and 4 share a 2. They both have x's and y's. The smallest exponent is a x to the 1 and a y to the 1. So the GCF will be 2xy. And when I divide this out, 2 divided by 2 cancels to 1. X squared divided by x leaves me an x. Y squared divided by y leaves me a y. Okay? And just kind of look at this. 2xy times xy gives me 2x squared y squared. So we're good there. 4 divided by 2 is 2. And the x cancels and the y cancels because they have the same number of variables. All right? When we look over here to the other side, we have a negative number there, so we have to say minus in between. We're going to divide by something negative. 7 and 14 share a 7. The variables are not on both terms, so they don't share any variables. It's just the negative 7. So negative 7 divided by negative 7 will be a positive 1. And the xy have nothing to simplify with, so we'll just have xy. Negative 14 divided by negative 7 is a positive 2. So let's go back and look. Xy plus 2, xy plus 2, that's our GCF. They've been divided out. What's left over is 2xy minus 7. All right, hopefully that was helpful. Let me know if you have any questions. See you in class.